Hi, Toby. Sorry about the other video. I don't know what happened there. I've never had that happen. I guess I was a little bit long-winded. um, I'm going to try to do this a little bit quicker and maybe even divide it up into two videos for you for the first and the last page. All right. So for your test, a couple of things to start off with. For number one, when you're proving that you've got similar triangles, you need to do it in a certain form, and it has to follow the form that I showed you in the examples in the content section for this section. So let's just have a look at the triangles themselves. Okay, so here we have triangle ABC and triangle HGF if we do it in order. And so what you need to do here is actually figure out which sides correspond and then show me that they correspond. So in other words, you can write like B, I can't write on that one unfortunately, so we'll write over here that like BC, BC corresponds to GF and so on. And so if you write all those out, then you can say, therefore, triangle ABC is similar to triangle GHF, and in brackets you're going to put side, side, side. Once you've done that, then you're going to say, therefore, pairing up the sides, 72 over 12 equals x over, and solve for your unknown side. So again, if you go back to the content in section A11, I think it is, and have a look at the examples that are provided there, then that'll make it a lot easier. Now, similarly, if you're looking at B, it's not going to be side, side, side. It's going to be angle, angle. And so you can start off by saying that angle F equals angle G, and what you would say is that that's given. And then you could say that angle FH, whatever that letter is at the top there, S, is equal to angle FHG. Sorry, I think I'm looking at that one wrong. Is that a T? That might be a T here for this angle here, for that vertex. The reason for that is that those are opposite angles. They cross, and so the angles across from each other are equal. Now that we've got two equal angles, we can say that the triangles are similar. So you can say triangle TSH is similar to triangle GFH by angle, angle. Then you can say, therefore, and you can go ahead and figure out your other angles based on similar triangles, okay? So again, go back and have a look at the examples that are in that content, and then I think you will find that it's easier to follow, and you need to follow that same format for all of our questions, okay? So for question 2, in question 2, you're told that the triangles are similar, but something that you have to watch out for here is that they tell you triangle RST is similar to triangle BCD. Why was that not working? BCD. So what you have to do is follow the process. If they've got RS and BC written like that, then it means that side RS and side BC match up. Also, ST is going to match up with CD, and TR is going to match up with DB. And so what's happened here in number 2 is that you've got the wrong sides matched up. What you actually want to do is have SR matched up to CB. And so 11x minus 4 has to match up to side CB, which is 60. And then on the other end of things, we have ST matching up with CD, so we have 70 over 50. Now, if you solve that, and what I like to use is what's something called the Z pattern. A lot of my students like to do this. You start with the unknown, and you go across, and you go 70 times 60, and then the last one you divide by 50. So 11x minus 4 equals 70 times 60 divided by 50. And I think you'll find if you solve that equation that you end up with a whole number for x. Now, just so we don't run into the same problem, I'm going to make you a second video for question 3 and 4 and 5. So I'll send this one now, and I'll start a new one.